Hi and welcome to my channel. Today I thought to do a DIY electronics build. This is something I bought a couple of years back now. It's an 8x8x8 LED cube. Just take out the packaging. Now I not only bought the DIY kit which has all the components that you have to solder yourself, I also at the time bought the acrylic case, so you can actually then put it in there and display it. Now, like I say, this has been sat in my drawer for a couple of years now. I've just not got around to building it yet. I think at the time I bought this was about 20 quid, and this was about a tenner, UK pounds, slightly more than that now. I got this one from Banggood. This is an all blue LED one. I will put in the description a link to where I got this one from, although I think they've changed it slightly and the listing shows it's being rectangular LEDs, whereas this is the standard 5mm circular ones. Just move that to one side. So what does the kit contain? Well, as I said, this is a do-it-yourself kit, so we get a very nice PCB in black. It's about 155mm square, and like I say, it's an 8x8x8, so 512 LEDs. Now there are some surface mount components on here, and there's also a through hole one for the microprocessor. The surface mount ones are not too fine, so they shouldn't be too difficult to do, but obviously this is going to take quite a bit of actual soldering. We have a jig to allow you to solder the LEDs. Because obviously when you're doing this, like I say, it's 8x8x8, so you want to solder them in a 3D grid, and this design, this grid here is to basically help you get those soldered with the right distances apart, so you end up with a neat solution. Obviously the main part of this is the pack of LEDs. Like I say, these are blue. I don't quite know how many there are here. The bag says 1,000, but I don't think there are. I think I've seen things that say you get about 520 or so, and you need 512, so they'll obviously give you a few spares just in case. I've got bag of components and various wires. So here we've got the main microprocessor, some surface mount components. This particular kit comes with, if I can get it out there, a Wi-Fi module, so you can actually have an app on your phone to control how what the cube is doing. There's also a USB to serial programmer, so you can actually change the code on the actual microprocessor itself. That'll be the breakout cable for that. We've also got a power cable, so USB to a jack to actually do powering the board. There's an audio cable, stereo cable there. You can actually play audio through this if you wanted to, and actually get it to react to the music. And there's also a remote control, so you can actually change the actual static things if you're not playing it with music or things like that. So that's all the pieces. Like I say, I will be putting this together. Now you don't get any instructions with this. There is a download link on the actual listing to a zip file that contains a variety of actual things. Some of it is the source code for the actual microprocessor, so you can change it yourself. Some of the drivers for the serial download module, and also a few other things. And there's also some very, very basic instructions, but not really much, and they don't really explain quite how you use the jig and the LEDs. There's a few pictures of where you might put some of the actual other components on the PCB, but the actual silkscreening on this is fairly reasonable, and most of the components that are duplicates, they are the same component, or look the same, they are the same components, so there's a lot of repeated components here, so it's not too difficult to get the actual components done the right way around, but it's more of how you use the jig and things. So what I'm going to do is I'm going to time-lapse build this, because obviously, you know, soldering 512 LEDs is going to take me quite a reasonable amount of time, and at relevant places where it'll be helpful for you guys to see actually how you do it, so how we do the soldering and how we bend the pins and what components go where. I'll perhaps stop that to normal speed, give a bit of description of that, and then we'll carry back on. So I hope you enjoy it, and we'll start building in a moment. So I'm going to start by doing the main PCB, and I'll do the arrays of LEDs. So the main PCB, it's actually got quite a nice silkscreen layer on this, so it should be fairly easy to work out what components go where, and also the orientation of the various ICs. The surface mount chips, the ones here, U6 or 9, 7, 10, oddly numbered, 8, they're all the 8-bit shift registers. U3, 2, 1, and I think 4 down here somewhere are the MOSFET devices. There's the main footprint for the processor IC with a couple of decoupling capacitors and the crystal. At the bottom there, U6 will be the IR transceiver, and C1 will be the electrolytic capacitor. If we move across the corner, the bottom there we've got, at each corner we've got an LED to illuminate the underside of the PCB. There's a row of 1N4148 diodes. You can see the grid of solder pads for the array of LEDs. U11 there is the 3.3 volt voltage regulator. J1 is the debug serial cable. P1 is the power connector. S1 is the main switch. And the Wi-Fi module there with JP1 is obviously the Wi-Fi module connector. The Wi-Fi module just plugs in, so you can take it out if you want to. And there's a capacitor, another capacitor there, and a decoupling resistor across it. So I'm going to start with the main components, or the large components. So I'm going to do the IC holder, I'm going to do the switches, and I'm going to do the surface mount connectors, or surface mount components, such as the 8-bit shift registers, and the MOSFETs, and the surface mount diodes, the surface mount capacitors, the resistor, and all the other headers. I'll be back with you shortly. Okay, that's the board mostly or completely populated now. I've actually been around and I've cleaned some of the flux off with some isopropyl alcohol. I've put the IC into the socket. If yours arrives a bit like mine, a couple of the pins were a little bit bent, so you have to be very careful and just straighten the pins out, and then just the easiest thing to do is to put them on the edge on a flat surface and just bend them slightly in, because they tend to be splayed out, they don't fit in the sockets properly. I've also got the pins on now, so we can do a bit of testing of this. So one of the first things I'm actually going to do in terms of testing of this is I'm actually going to put an LED into two of the sockets here. Now the positive is on the outside set of sockets and these are all negatives. So if we get one of the LEDs, remember the positive lead is the longest on these, so if I just insert it into each of these, I'll just put 8 of them in a line. I'm not going to push them in too far, just enough to make contact, just to prove this is going to work. Now you want to do this before you start assembling the LEDs and actually put them onto the base plate. What you don't want to find is that you've got some problem and then you won't know if it's the LEDs you just soldered or the base plate's not working. So this should give us an idea whether at least this first row is actually functioning properly. Okay, that's all of them in. What I'll do is I'm going to get a USB power bank, just a very simple power bank. I'm going to plug it in to the jet socket and I'm going to turn it on. Now initially you'll see the LEDs at the bottom here start to flash. These are colour changing LEDs, so they'll just do that anyway. And after it's sort of booted up for a while, there we go. It's actually now started to do a bit of a self-test. Now you can see here, it's going down each of the rows, or columns depending on how you look at it. And they're all lit nicely. I'm not quite sure what sequence it's actually going through here. I think it's just probably trying one of its test patterns. Somewhere, if I can locate it, is the button. That seems to have changed something. Not entirely sure what, because obviously we've only got one row here. But that does seem to look as if it's actually working. So that's a good start. You can then start to actually populate the actually arrays of LEDs. And that's a good test at, at least the baseboard soldering is what seems to be okay. So yeah, I think this is looking rather neat at the moment. So on to the next bit, which is to do the LEDs. I'll be back with you shortly.